Hello, we're back. I forgot to do all the examples, so we're going to do them in a separate video today. Okay, example 1 in the textbook, page 407. Says point O is the center point of a circle, and determine the values of x and y, excuse me. So we're going to use a couple properties here, and the first one being we've got an inscribed angle, and we've got an arc. Let me use a different color here. We've got an minor arc. How come my color's not changing? Oh, it was just lagging. We've got a minor arc between A and B right here. And so we can say that ACB is subtended by that arc. And ADB is subtended by the same arc. And because we have the inscribed angles property, we know that X should be equal to the same angle as this one. So we can say X equals 55 degrees based on our inscribed angle properties. And Y, we're going to use the, what property is that one called? Central angle and inscribed angle property. So if we know that X is 55 degrees and it shares the endpoints as our central angle, or they're subtended by the same arc, then we know that Y should equal twice as much as this. So we go 2 times 55 and we get 110. So Y equals 110 degrees. So that's the logic behind that first example. Let's go to example 2. So example 2, we've got this rectangle in a circle, and all of its vertices are supposed to be touching. My drawings are bad, I apologize. And we have a radius of 8.5 centimeters. The width of the rectangle is 10 centimeters. And they're asking what is the length. So they're asking basically what this is, that side. And this one at first, like these questions always kind of break my brain for a second before I can figure them out. So this one, the kind of first step to it is to identify if we have our radius going across, then we also have our diameter going from A to C. So our diameter should equal 17 centimeters, because 2 times 8.5, we get 17 centimeters. And once we have that, we know the diameter is splitting it into a half circle. Oh, sorry, my cat's being bad. Okay, he's good now. So we have that split into a half circle or semicircle. We know that this angle here is 90 degrees. So if we have 90 degrees there, remember I said if you are seeing 90 degrees anywhere, think about Pythagorean theorem. That's what we should do. So we have this entire side as 17, this side is 10, and then we're trying to figure out the final side. So we can just use Pythagorean theorem, right? We say x squared plus 10 squared equals 17 squared. We end up getting x squared plus 100 equals 289. And then if we go all the way through, we end up getting x squared 189, square root of both of those guys. And I think it's just the nearest tenth. Yeah, so we end up getting x equals 13.748. Final answer, x equals 13.7 centimeters. Or length equals 13.7 centimeters. Cool, let's get rid of that one. And we'll take on example 3. I just put a little note up here. O is the center point still. I just didn't want to make this more messy than it already was. Excuse me. So triangle ABC is inscribed in a circle. Triangle ABC, inscribed in a circle. Angle AOB is 100 degrees. So that's this guy here. And COB is 140. That's this guy here. Determine the values of X, Y, and Z. So the very first thing we got to find out actually isn't one of the properties we talked about, but it is a property of a circle that you should know. And that is, if we have angles going all the way around, they should add up to 360 degrees. So we can write, wrong layer, we can write that angle X equals, I shouldn't put that, I did it in reverse order. What we should do it in is 360 degrees, excuse me, equals 100 plus 140 plus X. And when we take away 100 and 140 from each side, we'll end up with X equals 120 degrees. So that's 120 degrees. Let's erase that and we can then start filling in a bit more of our chart, or more of our shape, excuse me. Cool. So our next step that we can do here is we got to find y or z. And if we investigate a little bit, we'll find that y is actually pretty easy to get because ABC is subtended by the same arc as AOC. And we know the central angle of AOC is 120 now. So we know that y, since it's the inscribed angle that matches up with that central angle, should be about, or should be exactly half. So we could say that y equals 1/2 of 120. So angle y is 60 degrees. And why don't we erase that now? $60. Okay, and the last one actually confused me for quite a while until I realized that I was missing a trait that we had learned a while ago, and I just forgot about it, which is the nature of these questions. So if you take the point A to O, that's the radius. That's our radius. And O to C is also our radius, which means that this is an isosceles triangle, which means this angle is equal to this angle. And we have the third angle. So we can say that, we can say how would we write this properly? Oops, 180 equals 120 plus 2z. Because we know that z has to be equal, and there's two of them, and it has to add up to 180 with that central angle there. So if we do our algebra, we end up getting 60 equals 2z. Divide both sides by 2, and we end up getting z equals 30 degrees. Oh, sorry, angle z equals 30 degrees. So these are our three answers for those angles, and you'll notice it's just kind of like a hodgepodge of different characteristics and traits and things that we kind of have to remember, properties that we have to remember. And it's tough, but you guys do have all the tools. You do know all this stuff. So if you're ever stuck on a question, don't worry about it too much. Bang your head against the wall for a little bit, then move on, and come back to it the next day. You might remember something that you didn't remember last time, or talk to somebody like me or another student and see if they can give you a hint or something instead of just telling you the answer. And it might just be the one thing that you need to figure it out. Cheers, guys.